my name here, if that's possible, in the... Voila, so you can see my name in the Zoom. Okay, so I work for Commonland, and so our aim for today is to explore a little bit about the effects of landscape restoration in Africa. So yeah, we are talking about the entire continent, or Jessica will talk about the entire continent of Africa, and then Ishani will still zoom into a specific case. And before we start, I thought it would just be nice to give a little bit of an context on why this topic is also specifically interesting for us at Commonland. And for that, I prepared a little presentation for everyone. So, let's see. Ooh, okay, now everybody sees everything. All right. So, greening in Africa, or regreening Africa, we sort of use both of these titles for this event. So for those who don't know, Commonland is a Dutch-based NGO that does large-scale holistic landscape restoration worldwide. And the approach that we use for our landscape restoration work is called the 4 returns approach, which focuses on ensuring that landscape restoration work provides returns in the form of inspiration, community, nature, and sustainable economy. So essentially, we have recognized that landscape degradation usually leads to 4 main losses in a landscape, which is the loss of purpose or hope, loss of jobs and prosperity, loss of biodiversity, soil and water, loss of long-term income. And research has shown, but we also truly believe this, that landscape restoration or ecosystem restoration leads to 4 major returns, of course, that you can disseminate a little bit more, but those would be the return of inspiration, the return of social returns, so thriving communities, natural returns, and financial returns. And a little bit more practically speaking, we do a lot of things at Commonland, and some of these activities include supporting landscape partners or our landscape partners in assessing their landscape holistically, so from this 4 returns approach. Then also we provide strategic support in the planning of restoration initiatives, and we also help with fundraising strategies. And then we also help landscape restoration activity initiatives that we work with to monitor their landscape better or more holistically, or from this perspective. And then we also aim to exchange our lessons learned and share the knowledge that we've gained through our restoration work. And now one of the things that we also do is that we have seen that measuring the success of landscape restoration is very complex, because there are so many different variables in holistic landscape restoration, and it's always very vital for us to learn better ways that we can monitor landscape restoration and navigate the complexity that it involves. And today Jessica and Ishani will show us some approaches or methods that can be used in researching the effects of landscape restoration. So this is sort of from our perspective, and just so that this is a platform, a very cool platform you guys can all check out. The session flow for today, I provided a little bit of an introduction, and then we'll have the presentations by Ishani, Jessica, and also Mr. Makui, who is a local Maasai who joined us from South Kenya. Then we'll have a Q&A, some conclusion, and some next steps or next things that we can do. Here's another overview of the speakers. Jessica, I'm going to introduce you. We're all here in the Commonland office together. But so Jessica is a PhD student at the Wageningen University and Research, and her mission is to understand the local climate impact of land restoration projects in Africa, including changes in precipitation and land surface temperature. Using satellite observations and atmospheric modeling, she is creating guidelines for landscape restoration projects to maximize their positive local climate effects, ultimately combating land degradation, arid and semi-arid areas. And Ishani, I'll also introduce you. Ishani Sonak holds a master's degree in climate science, also from the Wageningen University, and specializes in ecology and agroecology. She has extensive experience in environmental policy, land restoration, land acquisition, and social and environmental impact assessment across India and also parts of Africa. And complementary to Jessica's research, Ishani has been leading community-led research on landscape restoration, combining both quantitative data and qualitative data to assess the effects of landscape restoration efforts. Sort of a mouthload that I have written here. And then Mr. Makui is a Maasai from the South Rift. He's lived in the South Rift since birth and has over 20 years of experience in community development and conservation leadership. And he's also part of the project called SORALO. Maybe he'll also talk a little bit more about this when he speaks, as a team leader in conservation and restoration of South Rift. We're super excited that you guys are here, and without taking up too much more time, Jessica, I'm going to give you the floor to present your awesome research. All right.
Okay. Thank you, Milena, for this opportunity to present my research, and also, for the invitation. I'll try to share my screen. Is it okay?
Yeah.
Okay, good. So for my PhD research I do at Wageningen University, I study land restoration in Africa. And Africa is a continent with one of the lowest greenhouse gas emissions in the world, but at the same time it's already experiencing the negative consequences of climate change in the form of droughts, heat waves, more extreme events. And at the same time, dry lands in Africa are very vulnerable to land degradation. And there are many organizations that recognize these pressures we put on ecosystems and local communities. And they proposed a solution of land restoration. And this is, for example, included in the Sustainable Development Goals and also the Decade of Ecosystem Restoration of the United Nations. And there are many large-scale projects like the Great Green Wall or the Africa 100 project, and also, of course, these smaller initiatives like Common Lands. And the idea of this land restoration is to decrease, for example, land degradation, increase biodiversity, but some organizations also suggest that it can be used to create a more comfortable local climate. But until now, it's not really known how much land restoration causes greening across the Africa continent, and also whether we can actually use it to create a more comfortable local climate. So during my PhD research, I tried to answer the question, does land restoration cause greening in Africa? And also, to what extent can it be used to create a more comfortable local climate? And these are also the questions I will try to answer today. So we can, if we look at greening or an increase in green vegetation, I would say, we can of course go to the field and measure this, but on a very large scale, we can measure vegetation greenness with satellite data. And here on the left you see, for example, the MODIS satellite. It's from NASA.
1 second, Jessica.
Yeah.
I'm just hearing that the sound is very low, so maybe I will mute myself, and if you can unmute yourself.
Let's try.
Yeah. Oh.
Okay.
And now if you increase your sound, so you can, yeah, okay.
Okay, is this better?
Yeah.
Okay. Yeah, sorry for the for the interruption. I hope it's better now. So on the left you see here the MODIS satellite from NASA, and it can make all these very nice images of the Earth, but it can also measure vegetation greenness in the form of the something we call the normalized difference vegetation index, or the NDVI. And this, through measuring infrared and red light, we can say something about how much green vegetation there is present. And each 16 days, these kind of maps of Africa or the whole world are created of vegetation greenness. And if you look at that through time, you can say on how vegetation develops over time. Yeah, so then you get these time series for a certain location of observed greening. But then if you want to evaluate, for example, how much greening a certain land restoration project causes, you run into one problem, and that's that this greening is not only caused by the restoration effort itself, but there's also an effect of large-scale climate variability, for example, changes in precipitation or changes in climate. And then if you want to assess the effect of the land restoration projects, you kind of want to remove this natural climate variability. So this observed greening is not only caused by the local greening, but also the background greening or the climate variability. And this together causes the observed greening. So for me, I try to remove this background greening. And how do I do that? So this is, for example, a time series of vegetation greenness over time. So on the x-axis you see the years, so it starts in around 2001, and on the y-axis you see the NDVI or the greenness. So the higher the greenness, the higher the value, the more green vegetation. And then in the end you see a sudden increase in vegetation greenness. But this is caused by land restoration efforts or by natural climate variability. So what we did is we assumed that this natural climate variability acts on a larger scale than the land restoration effort. So so you would expect, for example, that if greening at a land restoration project is caused by climate variability, then you would also expect to see this greening outside of the project area. So we took the average of a certain, around a certain point of this NDVI, and then if you subtract these two time series, then you get the amount of greening compared to surrounding areas. And then you see that also for this area, you see an increase in the vegetation or vegetation greenness compared to surrounding areas. So if you apply this method to the whole of Africa, then you get this map, and these green areas are regions that show increases in vegetation greening compared to surrounding areas. And then you see that this local greening or small-scale greening is mainly present in semi-arid regions, such as the Sahel area or Kenya, Tanzania, but also parts of southern Africa. And I think it's good to realize for this map that this is not necessarily all caused by land restoration, but it can also be, for example, changes in water level. So you see, for example, Lake Chad quite present here. And for example, changes in agriculture, so irrigation and things like that. So the next step we want to know is whether or not land restoration causes this kind of greening. So what we did is we used more than 400 sustainable land management projects from the WOCAT database, and these are projects like active revegetation, natural regeneration, but also a bit broader things like sustainable agriculture or things like that. And then you see here, you see the locations of these projects and the amount of greening we saw at these projects. But then, of course, if you want to assess the greening amount of sustainable land management, you want to know if we see more greening at these projects than in other areas, for example. So it's some sort of statistical approach. So what we did is, and this is kind of a complicated graph, but on the y-axis you see the amount of local greening at these project locations. And we use the VOCA database because they have quite a lot of projects around Africa, but the problem is that they only provide point coordinates, so not the actual area of land restoration. So what we did, we looked at certain ranges around this point coordinate, and these are what you see, the green dots on the x-axis. So these are different ranges around this point coordinate. And then you see that if you compare the greening of these projects with a certain reference area, that the greening at the projects is much higher than at the reference area. And if we then extend this for revegetation and natural regeneration, so these are sub-regions or subcategories of the sustainable land management, then we see that revegetation has high greening, especially close to or in smaller regions, while natural regeneration we see a bit less greening, but more greening in larger areas. So from this we can conclude that land restoration does cause greening in these areas, and especially in semi-arid regions, and we also saw that revegetation causes stronger greening than natural regeneration. So my next question was to see to what extent we can use land restoration to create a more comfortable local climate, and for that we combined these observed changes in greenness we saw in the previous slides with observed changes in temperature. And with that together you can say something about how much temperature change you would expect from land restoration. So we used similar data, but next to the NDVI or the vegetation greenness we saw earlier, we also extended this with land surface temperature or LST. And this can be measured with the same data. And what we did is we also again applied the same methodology as earlier. But now we removed the climate variability for We removed the climate variability for both the vegetation in green and the temperature in blue. And then we can say if an area is greener than its surroundings, will it also be cooler than its surroundings? So we use these NDVI temperature relationships together with a map of potential vegetation due to land restoration to predict the local cooling potential of land restoration. And we did this with a machine learning model, so a random forest model. Here you see the map of the potential NDVI we created. And we use this, so this is the NDVI or the vegetation greenness that could be reached given certain climatic constraints. So for example, if you have a certain aridity, certain temperature, how much NDVI we could potentially obtain. And then on the right you see the difference with the current NDVI. And I think it's important to note that this is only constrained with climate and not with socio-economic factors. Thus there's no land allocated, for example, for agriculture or cities. And if we then combine all this data, we get this map. And it shows the change in surface temperature due to land restoration that could potentially be obtained. And then we see that large areas of Africa, so the blue areas, have a cooling potential due to land restoration. While in some regions, for example in the driest regions of the Sahel, we see a warming potential. And Now you probably think, like, why do some areas show warming and other areas show cooling? And I will try to explain it very easily for you. So most energy, so the warmth of the surface, it comes from the sun, right? And in low vegetation areas, this energy from the sun is used for the evaporation of water. And the remaining component is turned into heat. And at high vegetation regions, this basically works the same. But then there are two main differences. And the first is that higher vegetation cover is usually considered darker. So a darker surface absorbs more energy from the sun. So this means that both the energy used for evaporation goes up and the heat goes up. And this is what we call albedo warming. So that's the albedo is the amount of reflectance from the sun. And at the same time, a high vegetation cover usually evaporates more water. So this means that more energy is used for evaporation and less for heat. So this will cause cooling. And so you have this balance between albedo warming and evaporation cooling. And in most areas in Africa, you see that this evaporation cooling is more important. But apparently, in the driest regions, you maybe not have enough water available for the evaporation of water. So in this case, a higher amount of vegetation will cause warming. And so if you have also this increase in evaporation, maybe you would also get an increase in rainfall or cloud cover or the water balance. And I guess that's for future research still to discover. So what we saw is that land restoration can cause greening across Africa, and it can also cause cooling, but probably it will cause warming in the driest regions. And I think now for me the next step is to study how land restoration can alter the water cycle. Can it create more rain, more cloud cover? And then the final step for me is to combine all these things that I found in some guidelines for land restoration projects. So thank you.
Thank you. Do you want to unmute yourself again, and then I'll unmute myself. And great. Perfect. Thanks. Yeah, it's gonna be a bit complicated.
It will be fine.
But thank you, Jessica. It's interesting because I've seen part of this presentation before, and every single time there are new questions that pop up, that things I haven't thought about yet. I also just want to say I am going to, for everyone who's interested in reading the full paper of what you just presented, what is published, I just posted the link in the chat. And also, as a reminder for everyone, if you have a question, please put it into the Q&A section. We'll move to Ishani in just 1 second, but I actually have a few questions.
Yeah, sure.
And I prepared a few questions in advance. I might catch you a little bit off guard now with extra questions.
Oh, well, I will try to give a good answer to them.
Okay, great. You might have to speak a little louder, or I'll try to bring my computer louder to you a bit.
Move a bit closer.
Yeah, so that you can hear it. First of all, I was going to ask you if you could provide a little bit of more of a definition of what you mean with greening in general.
Yeah. So what I use for regreening is an increase in green vegetation cover.
Okay.
And that's something that you can measure in the form of a DVI.
Okay. So that's the spectral data, right?
Yeah.
Yeah. Okay.
Yeah, exactly.
But it doesn't give really context to what kind of vegetation is there. It's just
no.
Yeah, just the amount.
So you look, at least I look from a very, very far away point to regreening, right? On a very large scale, but you can't really say, for example, changes in vegetation type or whatever.
Yeah.
You can't really measure that, and that might be a problem if you have, for example, like encroachment of invasive species, things like that. It will all show up as greening.
Greening, right.
Yeah.
There was one question in the chat, but before that, I had it's maybe a little bit of a controversial question, but I thought about it as I can. I was wondering if you can really say whether or not the landscape restoration projects cause the greening, or if the landscape restoration projects happen just to be in areas where there is more greening.
Yeah.
Or is it just a very strong correlation?
At least you can say that it's caused by a small scale process, right?
Okay.
Sorry.
No, take water.
Have a bit of a cold.
Don't worry.
Yeah, so at least it's a small scale process. And whether or not the restoration is caused or not, or the greening is caused or not. Yeah, I think you need to always look into each project specifically, and I think that's what Ishani
is going to present. All right, there's one last question, and then we'll move to you, Ishani. I think we can already. Okay, so Dylan Hooks asks in the chat, curious to hear why you think your results showed that revegetation led to stronger regreening than natural restoration, if the amount of land is so much more significant for natural regeneration.
Okay, yeah, so I think it's partly because revegetation often leads to a very strong immediate response, right? Well, natural regeneration can take a much longer time.
Right.
And I'm partly constrained by the length of time you have in the time series. So I think that's partly why this is the case. But of course you can regreen often much larger areas with natural regeneration.
Right, but the smaller areas they also get the support from the people who are, or from the people who are working in these projects, right?
Yeah.
Like, there's a human role that we can play in speeding up these kind of processes.
Yeah.
All right, let's leave it to that for now, and then Ishani, I'll give you the floor, and we'll talk a little bit more about, what does regreening look like on a very specific, zoomed-in case.
Am I? Yeah?
Yeah, I'm going to stop my video, and if you can also unmute yourself and put on your sound, then I'll unmute myself and people can hear you well.
All right. I think it's better because I'm linked through this for the recording. So
Yeah, that's fine. It's just so for the attendees.
Yeah. Hi. Am I audible? Okay. Thank you so much, Jessica, for your presentation, and also thank you, Milena, for having me. I would like.
Oh wait, they cannot hear you. Are you unmuted?
No, I did not join the audio because of this recording, so
Okay.
it's only through you I can. Yeah.
Okay, I understand. All right. Some technical hiccups are always normal.
Yeah.
So hopefully it works now.
All right.
I see our presenter.
Yeah. All right. Thank you so much, Jessica, for your presentation, and thank you, Milena, for having me. So I am Ishani Sonak, and I recently.
But we can't see your presentation yet. Are you sharing your screen?
Yeah. Yeah. And I recently graduated from Wageningen University with my master's in climate studies. And for my master's thesis, me and Jessica, we conducted a research on basically assessing the biophysical climate effects or the local climate impact and social impacts of land restoration project in south of Kenya. So basically, as Jessica introduced already, that regreening or land restoration projects have many effects, which are, let's say, biogeochemical impacts, so increase in vegetation cover, increase in soil organic carbon or soil organic matter, but it has biophysical effects such as increase in soil moisture or the evapotranspiration cooling, as she explained in detail, so I would skip the explanation. But it also has significant social impacts. Now, the objective of the research that we undertook on a more local level was to understand how actual versus perceived impact of land restoration project can ensure socio-ecological resilience. Now, why are we talking about this? Because a lot of investment is going into land restoration, regreening, and often we hear generally quantitative data coming up. So like number of hectares were regreened or number of trees were planted, and less often local considerations are talked about. So to understand how the actual impacts, so in case of land restoration, how much vegetation cover was increased because of restoration efforts, what impact this vegetation cover had on the local climate, so land surface temperature, as Jessica mentioned, and how the two processes impacted the lives of the local community. So also understanding the actual impact of vegetation cover and surface temperature, and understanding how it was perceived by the local community. And furthermore, if the local community benefited or did not benefit from these restoration efforts, and if it did benefit, they will reinforce the restoration efforts, which will further increase the vegetation cover and ensure a positive feedback loop. And that is what the objective of the research was, to see if socio-ecological resilience is possible using this methodology in restoration efforts. Now, narrowing down from a more continental scale to a more local level, we reached out to Justdiggit, MetaMeta, Aidenvironment, along with their local partners who are implementing land restoration efforts in south of Kenya and north of Tanzania. But for this particular study, to understand the changes in vegetation cover, we focused on the Ogali Makui Group Ranch, OOGR, in Amboseli, Kenya, as the implementation of efforts were being taken since 2019. And we also looked at SORALO in the green area, where the implementation was happening still in the last year. Now, to give a bit of cultural context, this area is predominantly inhabited by the Maasai community, and the livelihood is pastoralism or livestock management, and it's not only a source of income but also the identity, the cultural heritage of the community. A bit of a geographical background, the area experiences a bimodal precipitation regime, so it sees 2 rainy seasons, and it's because of its proximity to the equator and the intertropical convergence zone due to the pressure belt movement. And it also, the climatic patterns are also heavily influenced by El Nino southern oscillation, and can be quite responsible for excessive climate variability, interannual variability in the region. Keeping this background in mind, we can move into when I actually stepped on the field last November in 2022 2022 November, and the first confrontation for me in the field was that the area was seeing the largest drought in past 40 years. And having had the opportunity to interact with the local members of the community, the droughts are quite common as a way of living, as it's a semi-arid region. These are rangelands, and there is this particular drought was lack of rainfall for past 5 or 6 even consecutive rainfall seasons, and because of that, the topsoil is completely loose in the region, and even if there is a little rainfall, because there is lack of grasses, there is nothing to hold the water intact, and the water just runs off, and the community is very motivated to do something for its own survival and the survival of the walking ATM, as the gentleman called it, as in their livestock. But the restoration efforts per se implemented by the project developers in the area since 2019 were, I'll give you a bit of context. So for formalizing Maasai grazing management, so the Maasai community works on the ethics of common property resources. The land is communal and can be accessed by all. And for this communal land management, there are certain grazing management practices and grazing committees. And as I mentioned that the area region experiences bimodal precipitation regime, there are designated seasonal grazing areas. So there are dry season grazing areas and there are wet season grazing areas, but there are also designated areas near the Maasai homesteads or bomas, which are called olopololis. These areas are designated only for young, weak, or pregnant livestock. So maintenance of olopololis and seasonal grazing areas is kind of a way to keep in check the ecosystem, the species composition, the regeneration, and pressure management on the land. And the second, so maintenance of olopololis was the first intervention. Second intervention was basically formalizing these bylaws that is set by the local community members, grazing management plans, etc. And there were then physical interventions undertaken, which was rainwater harvesting structures were dug. So as you can see here, this is a soil bunt. It was being dug while I was in SORALO region. And these are the trenches. So the trenches and soil bunts were dug from upstream to downstream, and they were then reseeded with grass seeds so that the water percolates and the grass seeds can sprout. Now, the methods that I used to assess the impacts of the restoration efforts were basically using the same technique as Jessica, so like a donut model or a before and after control impact concept. So the green area is the actual restoration area, and the blue area here is the reference area. This will come up in my results, but it's the same concept as Jessica has explained. For data collection, of course, for understanding the perceived impact and the social impact of the restoration efforts, I used focus group discussions and key person interviews. However, I did have a semi-structured questionnaire, but my questionnaire was really guided by the discussions that I had with the local community members. It was quite participatory. And then for the NDVI and LST, I used the same data set as did Jessica, with using the MODIS satellite, and was analyzed in Google Earth Engine and R. And for statistical analysis, I used a KIK information criteria. It was just to assess if the intervention had a significant impact. So to answer the first question that we talked about is the restoration effect on NDVI. Now, before I explain the results, I would just give you explain how this plot works. So you see that on y-axis, this plot shows the difference in the intervention areas, or say the olopololis in this case, and the reference area, so the areas right outside the Olopololis which were not managed as against Olopololis which were managed. So if you see a point on 0, it means there was no difference inside or outside the Olopololis. However, we observe here that all the dots are above 0, implying the NDVI was always higher inside the Olopololis versus outside the Olopololis. And here when you see the red line, it is post the intervention, so it's post 2019. 2019 onwards, we do not see particularly an increase. However, we still do see that all the points are above 0, implying that the Olopololis had a higher NDVI. And similarly for the buns area where the buns were dug, we can also observe similar trend that vegetation was always higher from 2000 to 2022 inside the buns area, which was also formerly an Olopololi. However, since the implementation of the project, we did not see an increase. Now, why we did not see an increase? From literature, we can say that the area, as I mentioned, is prone to interannual climate variability, but is also prone to droughts. And as I mentioned, that 6 consecutive rainfall seasons had failed. So this decrease or lack of increase in vegetation can be attributed to the climate variation in the region and extreme weather conditions. Now, what did the Maasai perceive from this vegetation? They also perceived that there was a decrease in grass availability. Now, in detail and in length, the community members go to explain why do they think so. So, of course, as I mentioned, the drought was the key factor. But they also mentioned population pressure, that increase of population in the community, and also overstocking. So overstocking is not only the number of cows went up, but it also is a shift in the livestock mix. So from cows, now the mix is shifting a bit towards sheep and goats, also referred to as shoats in the area, and it's probably because of extreme climate variability. It's easier to maintain shoats than cows, so there is this drastic shift observed, and they're cheaper, so they are bought in access for easier cash. And of course, the overstocking is also possible because of improved financial services in the region. So now the members have access to loans, and they can plan their livestock mix better. Another aspect that was quite predominantly present in my field trip was land privatization in the region. So as I mentioned, it's a communal land which is now being privatized for agricultural activities or ecotourism for resorts, and the land is facing a lot of pressure because of that. So now the same amount of community members, the same amount of livestock, but lesser area in hectares for grazing. So that is leading to a lot of pressure on the land. And another thing about grazing management and how the community perceived that the intervention of formalizing grazing committees or formalizing grazing management plans is good, because earlier traditionally in grazing management, if somebody would flout the rules of an Olopololi, the community elders would curse them or declare them to be an outlaw, and the pastoralists would fear this, and this would act as a deterrent. But now, due to a shift from traditional Maasai beliefs towards Christianity as a religion, they don't believe in curses anymore. So that's why there has been observed a bit more often a flouting of these rules that are set by the local community members together. And the last but not the least that was mentioned, that the community or the grass species composition is changing. So now they see predominantly 2 grass species, and which are not the most nutritional ones. And apart from that, there is a shift from grasslands to open tree lands, because of excess of, for example, shotes eating acacia tree seeds and dropping them around in their droppings. And there's also a great threat of invasive species. And for example, when I was there, Prosopis was in SORALO area, not particularly in Amboseli yet, but that was also a fear that the invasive species might take over. So these were certain perceptions about the vegetation that said way more than actually what the satellite data showed. And now, coming to the effect of vegetation on LST, so as Jessica mentioned, that if there is a higher NDVI in a region, we would also, or we might also see, or we did see in her continental aspect, a lower LST or a cooling effect of the vegetation. But in this particular case, as you can see, again, I have used the same technique on the y-axis. Shows the difference inside and outside the olopololis, the difference of temperature. And as you can see that unlike NDVI, there is no consistent trend that is being observed. It cannot be said that if the NDVI was perpetually higher in the olopololis, the LST is perpetually lower. That cannot be said. However, in drought years, we can observe, for example, since 2020, that the NDVI tends to be higher in, the LST tends to be higher in the inside the olopololis as compared to outside, and also is the case for the buns. Now, how can we explain this? As Jessica said, that limited water availability, which is the region is quite prone to, reduces the potential of evaporation to cause cooling. So that is one aspect that we might not observe of that. And secondly, there might not be enough soil moisture to buffer the land surface temperature. That's why we also don't observe the direct correlationship between NDVI and LST. So it's safe to say that biophysical effect of vegetation is more complex at a local level. How the Maasai perceived the temperature, interestingly, they felt that it was warmer, but I think it was not particularly with respect to only these 3 years of post-intervention, but a general perception of temperature that they have been perceiving it to be warmer. Nonetheless, there is high hopes from the physical interventions that the gentleman or the community leader there explained the entire surface energy balance that Jessica just explained in her research presentation, the entire explanation of the evapotranspiration cooling effect, and that was quite interesting to look and observe. But apart from the perception of the impact, there were several challenges that were mentioned by the local community members who were involved in implementation and decision making of these efforts. Is that the one thing they perceived was that these bunds areas, or all these intervention areas, including olopololis, so traditionally or even now after implementation, these areas are not fenced. So these areas are not fenced, and these areas are intensely populated areas, as in the wildlife is in close proximity and is in synergy within the ecosystem. So you can see that here inside the bunds, these are the zebra hoofs, and the little grass that cropped up were instantly eaten by the zebras. Here you can also see, well, barely, but you can also see a cow near the trenches. So again, livestock could access these areas, so did not get enough time to regenerate. And then also that sometimes when heavy rainfall was observed, upstream especially, it was perceived that the bunds were not stabilized enough, and they were not stabilized enough to hold that water. So that was another challenge that was perceived by the community. And not only pasture availability, but water availability is also a challenge. And Siltation was another very big challenge, which of course if the topsoil is loose can be observed. So there were recommendations also made by the community to fix these challenges, and this was a year ago, but recently I just saw on Justdiggit's website or social media that they have now put dry branches inside these bunds and inside these trenches. And it's like a very nature-based solution. No fencing is done and nobody is really employed, but it's like dry branches have been put inside the bunds to ensure regeneration and enough time for the grass seeds that were sowed to crop up. Now, did the Maasai perceive benefits, or were there what was the socio-economic benefits of restoration efforts? Well, at the time when I was there in November 2022, there were no direct benefits that were perceived yet. Nonetheless, there were several indirect benefits that were perceived by the community members. So there was perceived positive impact by these restoration efforts, especially by the bunds that were dug in the area. So this lady next to me was involved in the implementation or digging of the bunds, and she said that she observed higher number of insects, bees inside the area, and also more water in around the area. Sometimes for quick access to water for domestic chores, they would go and use the water from the bunds. And this gentleman here explained, as I said, that he explained that soil moisture is key to having a cooling effect from these restoration efforts. And they already have started, with only little rainfall, they have already started feeling the cooling effect in the intervention corridor. So it was a livestock corridor, and they already have started feeling the cooling effect. And as I said, that there has been increased water availability. Well, I have not quantified that by myself, but this was the perception of the community. However, the siltation was still mentioned as a challenge. And last but not the least, community ownership, motivation, and especially women empowerment was observed. So it was not only that the women came together for the grass seed banks, one intervention that Justdiggit also implemented. It was not only that they came together for the maintenance of the area, the restoration area, but it was also that in their day-to-day living, they were more into a womanhood. So it was like a woman empowerment feeling. They've come out of their homes, and the husbands have let them work in these grass seed banks. There's a sense of community. So that was a great takeaway, as mentioned by these groups to me, for these projects. To conclude the entire research, we can say that the vegetation cover, or the NDVI, was higher in the Olopololis. So the traditional Maasai grazing management is effective and works, as can be observed by the satellite data. Maasai perception and remote sensing data matched for the NDVI, so it was said that the grass availability or pasture availability had decreased, and that's what the satellite data showed as well. But that could be, of course, because of a lot of climate variability being experienced in the region. But the same could not be said for the temperature, so the temperature did not show any particular trend in the satellite. However, the people perceived it to be warmer, rightly so if there is drought and lack of rainfall. Of course, that is because it is more complex, as I mentioned already. But involvement of local community from decision making or pre-implementation or in planning stage showed that there is acceptance and community ownership, and they're motivated, and this kind of involvement not only highlights the direct impacts but also the indirect impacts, which are key and essential in ensuring socio-ecological resilience and sustaining the restoration efforts long term, even after the project developer leaves the area or the region. Now, for recommendations of the research that we found from a local level, was that integrating community perception with remote sensing can give valuable insights into what is the challenge and how it can be fixed and how it can positively influence the area and how it can then, in that case, influence the restoration efforts impacts. But the second most important recommendation, having experienced this drought conditions in the region, was that it's better, or it can reap better results or better impacts if the restoration efforts are aligned with the climatic cycles or the seasonal forecast of the region. So it will be easier to show the impact positively, or have a positive impact, if the restoration efforts, especially the physical restoration efforts, are in tandem with the climatic cycle. But this leads to another recommendation, which is that in case there is extreme drought and grass availability or grasses are not going to crop up instantly, it's better to diversify the restoration efforts or the income generating activities in this case, so that not all the onus of livelihood or income generation lays on one particular restoration effort, but can be diversified into many, which was the case in this particular project. So there were many other things that were being done, so like beekeeping and hay collection, etc. So that can help. And also, if you are diversifying or not even diversifying, it's important to establish market linkages. So for example, if there is a grass seed bank and women are harvesting grass seeds, it's important that they know where to sell it and how much to sell it for. So this kind of capacity building can help the project or help the local communities even more. And last but not the least, I would say interim monitoring using this kind of methodology of integrating both qualitative and quantitative data can help identify a lot of issues at an early stage and ensure sustainability of efforts, foster acceptance and ownership. And during this process of interim monitoring, it can also ensure expectation management. So for example, the community felt that this project is going to increase the grass availability or pasture availability, but it did not. So managing those expectations of why it did not, or what happened, or what is going on, when can you expect increase in grasses or water availability, is something that can be done during these interim monitoring processes, so as to ensure that the hope and the motivation that the local community has from the project goes on. Because in the end, as was mentioned to me by a community elder, that they are the guardians of the land and they are the ones who are gonna be living on it. So it's important that the community's expectations are managed for success of land restoration efforts, not only for one project but as a perception in general. So I think that's my research. Thank you so much for listening.
It was amazing to listen. I was so hooked. Thank you so much for that wonderful presentation. Also to you, Jessica. Thank you for your wonderful presentation. Can you stop the sharing? Yeah, again, everyone is invited to ask their questions to Jessica and Ishani. What a remarkable master's project. Very, very interesting. And I have also lots of questions, and it's again a whole new thing to get the full presentation. I read the paper, obviously. But I was maybe going to, before we go into talk to Mr. Makui, who's also waiting for his part, I was going to ask you a little bit about the method or the process that you used.
Mm-hmm.
If you could just explain a little bit more on who you were interviewing. You mentioned the women. You showed some pictures. Who was part of your interview sample size?
So
who were the people you spoke to?
It was purposely done in a way, so purposive sampling, but it was done thanks to Mr. Makui, for example, in SORALO and in Amboseli region. I was also assisted by local partners, of course, because local partners were engaged with the local community before even the implementation of the project was started. So at the decision-making process, pre-implementation, and there were these key members that were involved in this entire process. So it was really nice to interview those members. And then also for the next level, as I mentioned, the woman that was involved in digging, so people who implemented the project and who were going to be direct beneficiaries from the efforts. But also, for example, some neighbors who were not directly involved in implementation but were around the area. So all of these people were interviewed. I also tried to interview local partners, so I interviewed Mr. Makui myself, and I interviewed local leaders so as to understand the governance landscape, just to put in perspective some policies of land privatization, for example. So this was more or less what I had in my mind, and then of course I could not do it myself in Ma. So always a local partner was available to translate English to Ma and Ma to English, and that's how it was done.
Amazing. You spoke also, you mentioned benefits, and I saw that Harma who also is an employee at Commandant, had a question about them. In your presentation you mentioned indirect and direct benefits of the landscape restoration initiative. Can you clarify what you meant with indirect and direct benefits, and also what kind of direct benefits was the local community looking for, or were you looking for?
So in the case as the interventions, I don't know if I can share, but as the interventions were mostly focused on maintenance of olopalolis and pasture availability. And another one that I did not in particular present in this presentation, but was grass seed bank development. So these were interventions that could directly translate into economic benefits. So for example, grass seed bank development could be harvesting grass seeds and selling it in the market, or harvesting hay and selling it in the market, or pasture availability is like a direct benefit that translates into grazing possibilities for the livestock, and then the livestock can be auctioned at the market. So this is what I meant by direct benefits. And what the indirect benefits were, the ones that could or not be directly translated into economic benefits, but had significant impact on the living conditions of the local community and the things that mattered to the local community. For example, the fact that the grazing management system is intact and is further being strengthened is something that was very key to the local community. So I think that was the indirect benefit.
Thank you for clarifying. I do realize, because we're in the same room, we're sort of talking to each other and not to the audience. So maybe we should not. I also noticed it. We're super great on time, but Mr. Makui, maybe I'll give you the chance to speak a little bit. And Jessica, if you want to also, I think you can show yourself again, so that we're all in the same. Mr. Makui, can you hear us? But you're unmuted. Yeah.
You want to see my video?
Hi, it's so nice that you were able to join the presentation. So first of all, it would be so nice if you could introduce yourself, who you are, and also what your role is in the landscape project, and also maybe share your thoughts on some of the information that has been shared, or some of the findings that Ishani has had for your landscape. I'd be very curious to hear what your thoughts are. But maybe introduce yourself first.
My name is Ogali Makui. I work for SORALO as Rangelands and Conservation Officer. Yeah, I work in the South Rift, and that happens also to be my home. I'm a resident of this Kajiado South, or Southern Kenya. Yes, and I've been working. It's quite difficult, Mailena, for me to say exactly who I am. Occasionally, it's good for people to say who you are. And yes, that's what I do. And I'm also a livestock keeper. I keep cattle, and I keep sheep and goats. Yes, and I work in restoration, trying to do restoration in South Rift. Yeah, incidentally, even now I was on the way from Olgulului, where I had gone with the community for an exposure and learning tour from Magadi to Amboseli area. Yes.
And when you see these factors, these data, what Jessica has shown, that these restoration projects are actually having a regreening effect across the entire continent of Africa, but then also what Ishani has shown, that this global data is actually really representative, or satellite data is also really representative of what the local community is experiencing. What are your thoughts on this, on that?
Well, I think what's happening is quite as indicated by the data collected in the field by the various scientists, and even felt and expressed by communities. Yeah, it's important actually to collect data to indicate the trajectory of changes that are happening across the landscape. We have, like for example, the greening mission and restoration work. Yeah, it has quite an array of impacts on people, on the environment, and even the social cohesion, the planning and restriction of and restoration action. And even if all the impacts of these are complex, there is still a feeling that what's being done is having effects on the people, on the land, on their culture, on the biophysicals. You see that we have the issue of invasive species that are taking over the rangelands due to, of course, high temperatures, so many changes that are coming, the inability of the land to hold water when it rains. There is a lot of surface runoff. There is a lot of erosion and sedimentation and siltation of water pans, and all these things are happening and changing what's the microclimate, changing the microclimate to the meso, to the general climate of the world. And of course, even our small spots where we work are part and parcel of the big world, where climate change is affecting, where things are happening. People are trying to enhance their resilience. They are learning from the interaction with partners like SORALO and Justdiggit, and researchers like Ishani. When we encounter these researchers, they bring, knowledge in a different perspective. We want that kind of science to interpret so that people who truly need it can learn, that can understand more, because there is always so much to know of what you already know. And different perspectives in the scientific research, scientists like Ishani and the other lady, Jessica, they actually bring out, the knowledge out there in a different format. And would be nice always to bring back this information to the local communities so that they can consume. Mm-hmm. Because we work in communities where their exposure to formal education is different. Some have not had time to go to school by virtue of various other factors that are social, cultural, and others. And of course, sometimes time and space determines who go to school in these rangelands. And some of these things have got long-term and very complex reaches, like the policy, the national policy, the local government policy, investment in terms of national interventions in planning and all those things. And all these things happen until they affect even the soil particles. You can actually attribute so many things to a good policy, good implementation strategy, the uptake by the community, scaling up, and all these things. All these things matter for sure, Maidana.
You mentioned some of these things already, but I would be very curious to hear more about what opportunities and barriers you see for landscape restoration in your region.
There are quite a number of opportunities. The landscape is ripe for interventions that have got, low technology, like just those physical efforts. There is so much degradation. There is also an opportunity to intervene in terms of knowledge and how it is done. Like, for example, when Justdiggit came in and SORALO and they partnered, and they used simple basic tools to create what they call the soil bands and water retention ditches that can hold water longer, and people can do it, like stone lines, basic simple things that truly slow down the surface runoff on the land, and that enhances the absorption or percolation of water into soil and increases the length of time that moisture is available, so grass growth is enhanced, and or vegetation, any other vegetation that is opportunistic can also grow, and that actually increases the biomass within the landscape where the interventions are carried out. And because everyone now is feeling the impact of climate change, there is an opportunity for other agents, whether scientists, institutions, foundations, to come in and work with local people to enhance the technology uptake, and people are actually to start now working on the land. We have seen the community appreciating those efforts and wanting more of it. That's an opportunity. And that enhances their resilience and coping and mitigation of extreme weather events.
Thank you. I was actually, you mentioned also a lot that, the local communities can really also benefit from this type of research. How do you think NGOs like Common Land, for example, or Justdiggit, or other organizations, what role can they play in getting also more of the local perspective and the local knowledge that is present in your region?
Thank you for your question, Milena. I think when we have these scientists and this kind of level of information, they can inform local county government policy, they can inform the national policy, and once policy is in place, then that is the only way local investment in terms of government and other resources can be put into a place. And of course, these physical experiences by the community who are not able to put it in a scientific and policy manner may not necessarily capture the interest of policymakers at the national level. And there is, of course, those who do research mostly are exposed people. Those are people who know so much in terms of reading through books. And once this knowledge they cultivate and gain from research bears on the answers the community needs, and answers the needs of the community, I think we have an opportunity to do something better. So where we use high-end science and local people understanding it in their way, in their perspective, I think it can enhance restoration effort. We have seen revegetation in plots where we have done restoration. We've seen some patches of green that didn't exist before. People actually say temperatures may have decreased, but they don't have thermometers, so they can't measure. But I think people who live in space know what happens around them, even if they cannot document in a scientific manner.
Very, very beautifully said, I think. I'm asking you all these questions, Ishani and Jessica. I'm sorry. I'm just, it's such a great opportunity to speak to you. And I do have one more question, which is that, of course, now you had Ishani came from the Netherlands to do this research. And I'm assuming there's also some barriers there. You mentioned the language barrier to be able to speak to the local communities. Do you also see foreign researchers coming into the area, and then also, do you see increased interest in also South Kenya, in research institutions in South Kenya to research landscape restoration efforts?
Certainly, I think that was quite opportune. Ishani came when we were going through a very severe drought, and I think there is also an opportunity to, share this knowledge through, if there are, for example, some kind of opportunities for young people from the community to study who actually know the language, the local language. If they got an opportunity, for example, to study in the university, maybe do their masters in environmental science and look at these things, and probably even translate some of this scientific language to their local languages, perhaps the uptake will be much greater. And also, there is a lot of opportunities for partnering between even Common Land and SORALO and or any other partner like Justdiggit, and bring in their knowledge. I think what is required, we always say, if you draw the sphere of knowledge, so little is known, and more knowledge opens more opportunities, create more spaces for people to work together, and even across cultures. I think the universe is all ours, and if we are able to partner to raise each other through sharing knowledge and skills, that furthers the global good of trying to address the issue of climate change and regreening the world, not only Africa.
Yeah, I agree with everything you said, and it's very nice and beautiful. You mentioned SORALO quickly, and I just realized there might be people in the audience who don't know what SORALO is. So maybe and I see it's on your pullover, on your hoodie. Maybe you can just say a little bit about SORALO, what you do.
SORALO is a local non-governmental organization. That means South Rift Association of Landowners, who came together to work together for the common good. And our mission is trying to create space that is, open and healthy, and it can sustain the local livelihoods and also enhance the protection of natural systems like rivers, like wildlife, all that natural system that supports livelihoods, and create space and provide an avenue for people to discuss what they are doing. And we work guided by 5 principles. Of course, they are in Maasai language. So if you visit our center like Ishani, we'll tell you what they mean. So you're welcome, Eliana.
Thank you. Maybe I will. I'll try to convince Kamala to send me. All right, I'm just going to move on maybe to Jessica and Ishani, because you guys haven't said that much, but and maybe we'll come back to you again, Mr. Makui, and if other people have questions for him, put it into the Q&A.
Do you mind if I mention just one thing, please?
No, go ahead. Yeah, we have time.
Yeah, there was something Ishani was talking about, the impact of restoration work. And I think there was so much direct impact, and there was indirect, as she says. There was, of course, the income generated through the, partnering, and people are paid to work on some of these things. Many people are gaining. They got money from the manual labor. They got the grass seeds, and then that, of course, they enhanced the milk production of their livestock. The livestock became healthier, and people got something to eat. And I think it's a bit complex to measure social impact, but still there. And we know, we have documented the number of people who worked on this project and the amount of income they took home as they are earning from their effort.
Mm. Thank you for adding that. Ishani, do you have anything you want to add to that, or
no? I think it's rightly mentioned that it's difficult to measure the socio-economic impacts. And in this case, the definition of direct impact, as asked by your colleague, was also like the direct, increase in grass availability and grass seed bank development. So it was narrowed down to that. But as I mentioned, the indirect benefits, like, for example, the money that was received for digging these bunds came at a time where droughts were at their peak. So I think that the sustenance for the families in that moment, I think, was the biggest direct impact there could be. So, but in terms of the research perspective, that's how the definition was. So thank you so much for adding that.
All right. Thank you for adding that in. We'll move to Jessica. So we're zooming out again onto the continent. We have still 9 minutes left. So yeah, again, people want to ask more things. I'll just otherwise go ahead with some questions that I have for you. So you talked a little bit about the data that you used, and could you maybe talk again a little bit more about the data that you used to get to get this global analysis? How reliable was it, and what role do you think NGOs like Commandant can play in providing better data also for researchers like you?
Shall I unmute?
Yeah, you know what? I think I'll just move my computer closer to you so that we don't have to get these technical issues the whole time. You can see the background.
Okay, I hope this works. So for like the continental analysis, I used MODIS data, and this is provided by a satellite from NASA, and it's freely available. So I called it from the Google Earth Engine library, and that's a platform where you can also analyze the data. And yeah, I think it is quite reliable. So the NDVI has a 250 meter spatial resolution, and the temperature 1 kilometer spatial resolution. So there are some downsides. So if you have very small projects, then you might not be able to capture it. But we also tried like the same methodology for Landsat data, which has I think a 30 meter resolution, and then the results were pretty similar. So I think in the sense of the like physical data, it's quite reliable. If you then look at the project data, so the WOCAT database, I think it's very great. It's very great that it exists, because it's quite hard for me as a researcher to obtain like this project data. But the downside is that it only contains like point coordinates, and it's not always clear how big these areas are or what the exact boundaries are. So I think it's important for NGOs like Commandant to share where the projects are taking place.
Thank you. I'm just gonna go into the chat. There's someone wrote, Simon Rietbergen wrote, great if Jessica could respond to my earlier chat remark about warming potential versus tree density. And I'm just going to quickly see what that earlier remark was. The earlier remark, I think, let me see. Let's scroll. So Simon Rietbergen wrote, the warming potential of tree cover in the dry zones, the agroforestry literature says that intermediate tree densities lead to a net increase of water infiltration in the soil. Therefore, there should be increased evapotranspiration, but no warming. Again, it's a question.
Okay.
Yeah. Therefore, there should be increased evapotranspiration, but no warming. Yeah. If you could respond to that.
I think it's important to mention here that I used a data-driven model, so that's what I kind of extrapolated measured data. And one thing that's not really included here are these kind of physical feedbacks, and also no spatial feedback. So if you would really restore large large areas in these regions, then you have, for example, changes in water availability, changes in atmospheric circulation, and that's not something that you can, I think, can predict with using these kind of observation data. But we do see that in the data on the longer time scales that we see a warming effect of increases in vegetation.
Thank you.
But yeah, maybe there are other regions where processes work different, and this is mainly from a very large scale region where certain processes are important in certain regions. Yeah.
Hopefully, Simon, your answer was your question was answered. I want to also very interesting. Thank you.
Great.
I also want to just ask this question by Alex Orgello, who wrote, nice presentation. How did you arrive at regenerated is promising than natural, more promising than natural regeneration? I'm assuming is what was said.
Yeah. Yeah, maybe it's good to say that in my research I look specifically at greening, right? I looked only at greening, and we saw that active tree planting, for example, or active increases in vegetation causes a stronger or more strong greening than natural regeneration. But I think if we look at the holistic approach that you do here at Common Land, that's important to consider also that maybe if you look at regreening only, then revegetation has a stronger effect. But as I said earlier, natural regeneration can be cheaper, and it can maybe create a more natural species composition, or so I think you should take all these different things into account and not only look at regreening only.
Right. Yeah. Thank you for that answer. I'm just looking at time. We only have 2 minutes left, and I had a few questions for you, Ishani, as well. But we don't have so much time, and I kind of want to also wrap it up. So maybe I'll just keep it quite general for my last question, if that's all right. I just wanted to ask you a similar question that I asked Mr. Makui, actually, which is, what role do you think NGOs like Common Land can play in providing better community-led research or community data?
I think I would answer quite similarly to what Jessica said, that the NGOs like Common Land and, like, for example, Justdiggit can beautifully provide the opportunity for researchers like ourselves to go and do kind of a participatory research with the community, with what I learned when I was there from Mr. Makui or Kenyatta, a community elder there, and from Justdiggit local people. I think that was the core of my research, and I feel that sharing information of not only what all worked, but also sharing information on what did not work, or like the downsides, I don't know, negative impacts, I don't know, whatever marketing narrative there is, that a repository for all the things also that did not work, for collaborative learning, not only for the researchers but also like fellow NGOs, is something that can be very helpful for internal learning and evolution of restoration as a practice in the view of climate change, is something that NGOs like Common Land and Justdiggit can be very, very useful for. I mean, they are already.
Thanks. Yeah, it's just good to get your perspective on this. Thank you very much. So we're at the end. If anybody has any more questions, you can email it to us at Commonlands, or maybe you can also reach out to Ishani and Jessica directly. Mr. Makui, I wanted to say thank you so much for taking the time doing your field work to come in and share your perspective. It was very, very valuable. Yeah. And I'm just very impressed by the Wi-Fi connection. You spoke so well, and we heard everything so well. So thank you. Thank you for joining, and to you as well, Jessica and Shani. Thank you. Yeah, I will send out an email to everyone also with a quick survey of how you thought this presentation went, and whether or not you thought the webinar was interesting. And we'll also, maybe Ishani and Jessica, if you're willing to share your presentations, we can also send those around.
Sure.
And thank you everyone for joining and for tuning in.
Thank you so much. Thank you, Mr. Makui. Thank you so much.
Thank you.
Good luck.
Good luck.
Quietly.